first piece of material that we're going to use is some aluminum foil. We're going to put it on the scale and make sure that we have 0.2 grams. You can take that off the scale. Make sure your scale is at 0, and then put a piece of filter paper on there. We're going to record the mass of that filter paper in our data table. After we've done that, we're going to shred up the aluminum foil into a small beaker, which I will show you shortly. And then we're going to mass out 2 grams of copper chloride on top of our filter paper. As you can see, I have my aluminum foil torn up into very small pieces. I'm now going to take my filter paper, fold it up kind of like a little taco, and try and get all the copper chloride off the filter paper. And then I'm going to add some water to get this reaction going. And you can see that this is a pretty vigorous reaction. You can feel the heat from here. If we can feel the heat, we know this is an exothermic reaction. Now, it's going to bubble and fizz, and now it's kind of slowed down. If we look inside, you see we have a lot of brown material where we used to have aluminum foil. So, I'm going to take this material in just a minute, and I'm going to pour it through the funnel. Now, the way I make my funnel is to fold this in half, and then fold it in half again so that it looks like this. And in just a minute I'll come back and we'll filter this. Alright, so you see I've made a filter. I'm just going to put it inside the funnel. And sometimes it wants to pop right back out. Just give it a little squirt of water, and that'll usually keep it from coming back out. Now we're going to take the material that I already made, and I'm going to swirl it around, because the goal here is to get all of the brown parts out. Now we may have to take the rinse bottle, and now we have all of the material from our reaction is going through the filter paper. So you can see it's dripping at the bottom, and the water is going to slowly filter through. Once it's done, I'll come back and show you the results. Push the button. Alright, now that the water has drained through, or I should say the water and chemical mix, we're just going to reach in, we're going to take it out of the funnel, and we're going to go ahead and put it on a paper towel and let it sit there and dry. You can see we have a lot of other examples of this. That's looking pretty good. But this one here, we didn't get a complete reaction. And I feel like this one back here probably had way too much aluminum foil when they measured it, and so it didn't end up reacting properly. Now, we'll come back in a couple of days when this is dry, and then we're going to measure the mass of the filter paper and the product, subtract the filter paper, and we'll know how much product was generated in this reaction. We did the chemical reaction. It has to dry because we don't want to be weighing water, so we're going to put the filter paper on there, and we see that we come up with a mass of 1.66 grams. Now earlier I recorded the mass of my filter paper, and I believe it was 0.68. So that would mean, when I did the math of just the material inside is about 0.98. Now when you look at this, you'll see it's still got some color from the copper in there, and it's got some material that didn't wash through. That's going to add a little bit of mass to our cone. If we were perfect, we would have had about 0.71 grams in here, but we've got a little bit of leftover in there, so that's pretty close. And inside there, we have copper.
Mr. Boson, what's this stuff around the edge, the yellow?
The stuff around the edge, that relates to some of the aluminum chloride that didn't go through, or when it evaporated, it just stayed and it stuck. So that's our aluminum chloride, and this part in here, the bluish, is our copper. Now, in this reaction, our aluminum, we wanted to make sure it all got eaten up. So we used a certain amount of it, and we used more than enough copper chloride to make sure all the aluminum would get eaten. So the aluminum is what we call our limiting reagent. And we actually had more copper than we needed. So that's why we still have some left in here, and why we have a little more mass than we probably should have. All right, using our data collection chart, we're going to start off with the silver nitrate. We're going to put 3 drops, 1, 2, 3. You notice the drop comes off of the dropper bottle before it reaches the bottom. I close up the bottle, good lab technique, never hurts. And now I'm going to take 3 drops of potassium carbonate. Put 1, right away you see a white precipitate forming in there. 2, 3. So you look at that, you got a lot of nice white precipitate. Okay, so I'm going to go down from the silver nitrate to the sodium hydroxide. You could go across, it doesn't matter, as long as you keep track of what you're doing and you record your observations. Now you notice the silver nitrate, observation-wise, before we reacted, it's clear. You can't really see what's going on in there. The sodium carbonate from the prior one was clear. We get the sodium hydroxide we're using in 2 different places, so just be a little careful with that bottle. And you'll notice it's pretty close to clear as well. So we're going to put 1, oh my, look at that, 2, 3. Okay, obvious reaction. We put 2 clear liquids together and we get this kind of dirt sludge going on in there. All right, so the next one, silver nitrate. Again, we know the silver nitrate, it's clear. We put the 3 drops in, put the rest in the bottle, close the bottle back up, and we're going to look for the potassium iodide solution. And we have 1 drop. Well, look at that. 2 drops, 3 drops. So we started with 2 clear solutions, and here now we have kind of a creamy yellow, obviously a solid in there. Now our last silver nitrate test, put 1, 2, 3 drops in our well plate, and we're going to take some iron chloride. Look at the iron chloride and go, it's not a clear liquid. It's got a little bit of a yellowish color to it already. So now we're going to put our 1, 2, 3. I don't know whether you could see it, but as soon as I put that first drop in, we had kind of like a curdling effect, like you put lemon juice in milk or something. And now we have a solid or a precipitate in there. It looks a little bit like our first well plate. Okay, so I'm done with the silver nitrate. I'm just going to put it off to the side, and I'm going to go to my copper. Now the copper, you notice, is a little bit blue. Characteristic color of copper. 1, 2, 3. Close that up. And let's find our potassium carbonate. And we're going to take 1, 2, 3. And you can see we've got a little bit of a difference going on in there. So, next one. 1, 2, 3. And being careful, pick up. So now we're going to move on. Copper sulfate. 1, 2, 3. I'm going to go ahead and put them in the next well just to kind of speed things up a little bit here. 2, 3. Be real careful when you do that though, to make sure that you don't accidentally put the wrong stuff in there. So the next one we want, potassium iodide. Potassium iodide looks kind of clear. It has a teeny touch of yellow to it. Put in 1. Well, look at that. 2, 3. That was quite the reaction. You can describe that however you want, but we obviously have a precipitate. Now I'm going to take the iron chloride. Remember, the iron chloride's a little bit yellow and our copper is a little bit blue. So let's take a look and see what we get here. We put them together. Okay, and in this case we get a color change, but we don't have a solid in there. And if you think about it, we put kind of an orangey yellow in with a blue-green. That's just color change, and in this case we didn't have a chemical reaction. So now I'm going to take my magnesium sulfate and I'm going to go ahead and see if I can do. I'm going to be real careful. That first one was kind of a bubble. Okay, but just in the interest of time, again, if you were to do this in a lab, you would want to be very, very careful that you don't get ahead of yourself. All right, so now we're going to put the potassium carbonate. 1, 2, 3. Okay, really hard to see, but you do have a little bit of cloudiness in there. We can't get close enough to it with the camera, unfortunately, but we do have a little something going on in there. 1, 2, 3.
And this was the sodium hydroxide, right?
This is the sodium hydroxide.
Okay.
Yeah. And that's a little hard to tell. This is one of those times where sometimes you might want to have a different colored spot plate. If you were to do this on a dark spot plate, you should see that there is a little bit of a white precipitate in there, but we really can't see it. So now we're going to move on to our potassium iodide. Remember, it's got just a teeny bit of color on its own. We put it in there, and we get nothing. Move on from there to the iron chloride. The iron chloride already has some color, so when we put it down, 1, 2, 3, and it's really hard to tell whether something happened in there or not. Again, it really doesn't look like it. That's the color that a large quantity of iron chloride would look like. So our last one is sodium hydroxide. And we got 1, 2, 3. We don't need to do this one because that's when you mix 3 drops of sodium hydroxide with 3 drops of sodium hydroxide. You get 6 drops of sodium hydroxide. 1, 2, 3. information for later on, remember that it takes 20 drops to make a milliliter. Pretty important in Scotland Yard. Potassium carbonate. We'll put our potassium carbonate into our sodium hydroxide. 1, 2, 3. Nothing happens. Now we're going to take our potassium iodide. Remember, we didn't do this one here. We didn't need to. So we'll go 1, 2, 3. And I'd say that looks like nothing. And then our last one here is our iron chloride again. And that is 1. Well, that's obviously doing something. 3. See a major color change, and you can see it again, that kind of curdling effect. All right, now that you've seen all the reactions, your job is to figure out the new chemical formulas and balance those formulas. You might also think about some of the ones that didn't react and ask yourself, could they have reacted but we couldn't see them? If we couldn't see them, it may be because of the solubility rules, which we'll discuss further in class.